Let's talk about our application layer tests. Now, what you'll notice in the original project is that we have those tests in a folder under V1. Now, these are not unit tests. I am careful to say they're not integration tests because a holy war will start about what testing is, and especially at a conference, I will avoid that. So the other ones are unit tests because a package in Go is a unit of code. So I'm just going to call these application layer tests. They're really, in my world, like an integration test in the sense that we're going to test code from the route back through the call stack and back through the different layers and back up. So we can have a separate folder here with the tests in it at the app layer because none of this is reusable, none of this is being shared. We can organize our tests sort of separately here. And what you're going to see is for every for every domain that we have, essentially, right? Because we use this concept of domain at the core business package level. We use the concept of the domain at that grouping app layer handler level. So I've got these tests also at a domain level. They're all going to be one big sort of test. They're all in that same tests package. But we'll use subtests and stuff to be able to organize it. Now, if you look at the last two files, web, this is the stuff that I've now been refactoring. So all the other files are what I'm going to call old sort of testing. Web right now is new, and my goal is to have just the web tests here, where they're all data-driven or table test-driven. So I'm just going to share with you the web files at this point. But before we do that, we do need our main_test.go because we've got to do a couple of things to start these tests. You saw this already with the unit tests, right? We're just going to go start DB. We've got the defer on the stop, and then we can say run any tests that we're being asked to run. Not a lot there. You've seen this. But what's nice about the app layer tests is we truly can do all of them with a single instance of the database, as opposed to the unit tests that need their own databases. So then decisions could also be made depending on the code coverage you have. Maybe in CI, we only need to run the app layer tests because that does do full coverage. But at my desk, I'll do both, like unit. It's up to you, right? You have those flexibilities. What I'm going to say is don't walk away from the unit tests. I think there's value in them when things are failing sometimes. Okay, so like I said, I'm going to stick to the web test here because this is the new direction. I tried to get some of this done before our class started. I was glad I was able to do that. And I want to walk through some of the new ideas that I have here for the testing. Here, we could just say package tests because they're already application layer. We've got to use full APIs anyway. And I want to kind of walk through what I'm doing here. Okay. And I got to remember, even though some of this code is new, I've got to also remember a little bit of what we're doing. So what I'm going to do is just start with our test web function here and sort of break down what I'm doing in this function. And I think the rest will follow. So we saw this with the unit testing, right? I'm going to construct a new test right there. There it is. I'm going to pull out the core APIs that we have. Right now we just have that one. And then I'm going, see, this is one difference that we have from the unit tests. With the application level tests, we need a mux. So on line 29, right, I've got to call the API mux function from version 1 because we need a mux. The whole idea is that we're going to be testing this down through the mux. Now you can see that I'm missing that web test type, and I'm missing two functions from the test package that can construct tokens. And essentially that's going to be logging in those two users we have and getting tokens that we need for the calls that do require authentication. Now, if we go back for a second and look at the handlers for user route, remember that our create, here it is, in the original project does require authentication. So you know what I'm going to do? I'm going to come back into our user route here, and I'm going to add that middleware just to make this a little bit more, I think, closer to the actual project. So I'm going to require now that creating a user requires authentication. All right, or maybe what we'll do, not to break the code we have, I could do this, right? I'll leave users, and we'll just call this one users off. So we could play with that in the test on this version of code that we have. So I just want to bring that in. So you can see here that we need to add this test.tokenv1 function. So let's go back to our db test package. I don't think I added that in yesterday. Maybe I did. There's the token v1 function. It's part of that test type that we created. Let's go take a look at that again. I don't think I added it yesterday to db test. New test. Yeah, I don't think I added it there. Now, this gets actually ugly because we got to think about this for the project that we're at. V1 token generates an authenticated token for a user. And one of the things that it's doing is trying to look up the email and password for that user in the database. This is one of those users that we seeded, query by email. And then what it does is it looks up that information and it generates a token based on those claims. So if we want to actually get this test to work, we've got a couple things that we can do. We could quickly add query by email to our project so we can make this work clean, which maybe isn't necessarily a bad exercise here. I think we could do this fairly quickly and it would walk through those mechanics again. And then we could actually have this token call here working and the rest would work. So let's think about that then. How do we do a query by email at the, in fact, if you look at this, also, it's not even at the core level. We're just doing it at the what? At the store level. Interesting. I'm constructing just the store here. Now, that's a super interesting decision that I made there. I talked about we didn't want code to really bypass any sort of business logic. Go through the business layer every single time. And look what I'm doing here. I'm actually bypassing the business layer and going through the storage layer. I don't know if I like that. In fact, I don't even remember doing that. I'm not sure I would have liked to do that. So here's another point in the code where potential smell. Now, we're just doing a query, so maybe it's not a big deal, and this is just for a test. So probably because of that, it's not a big deal. But for sure, if this wasn't just test code, there'd be no way I would want this to ever happen. So here's a really interesting situation here, where for this test, we're just going right through the store. And if we were on a team right now, I would say, let's go grab lunch and have this conversation for half an hour and say how we really feel about it. Okay, let's add query by email to the system so we can have this at least. So what does all that mean? We don't have to do any changes to the migration because it's already the user table and we already have the seeds. So that's pretty cool. What we need to do is we don't have to do anything to our models because that's going to be our model for the query. What we need to do then is come back into user and bring in at least the store API that I know we're going to need. So core user, let's bring some in. We know that we're going to need storage support for that API. So we're going to assume that if you implement store, you know how to query things by email. We also know then that we want to extend our API, even though we're not using it in that test code. Let's just bring it in anyway. There's not much to this function. It literally is just a bypass for the store, at least today. That doesn't mean that there may not be more business logic tomorrow. But sometimes you have these situations where the core API is just basically wrapping the store API because there isn't much else to do with it. Okay, so then I think that's all we have to do from a business API. Now we got to go to our store. UserDB. We have to find that API that we've implemented already. There it is. Now we already have implementation, so I'm copying and pasting, but you can imagine these would be the steps that we'd have to do. So there's query by email. You can see here that we've got the select statement. Select these fields from users where email equals :email. So I need a value that has an email field with that email address. So here we just use a literal struct to construct a value with that tag that we can pass into a function that we don't have yet called named query struct. Now I want you to look at this API for a second because here's some of the work that I did to make working with the SQL databases easier. This really feels like Go, doesn't it? Look at this. You construct a value of this type set to its 0 value. You share it with this call, and you expect this call to do the query and then unmarshal the results back into this. This is super nice, right? Feels very much like Go. This is how we would be doing it if we were using the JSON package or something else. This type of functionality isn't necessarily that simple to implement, especially with the SQL server that has, in this case, it's one record, but in other cases with rows and things like that. So let's take a look at the implementation of named query struct, which we will find in our PGX package. All right. So it looks like what we have is an exported function. Let's go to our PGX package. Looks like what we're going to have here is an exported function that takes all that data that we talked about. We're using any to receive that value that we want to unmarshal into, any for the data related to that query. And then we've got an unexported function here, which is really complex. But I want to share a couple parts of that with you. Minus any hotel. So I want to log the query. I always do that. We've got some variables here for SQL rows and error. I've got a variable called within, which we're passing as false because we're not using an in clause. I could, for our purpose, just sort of get rid of that. But you could see that if you're using an in clause in any query, you have to do a lot more complexity. You could really get away from using ins. SQL has that concept of any, and it keeps things simpler. But I've run into a couple of problems where I had to say something is in this, say, list. And so that's where that logic goes. But the reality is we just need to execute this right here. We check for some errors, and then luckily struct scan does the rest because we're only looking for a single value. A single value. Now, what if we were looking for a collection? What if we wanted to bring back like that query call, a collection of things? Whew. That stuff gets a little bit more sort of complex. You'll see this named query slice function in here. If you notice something about this function, what do you see? We're using generics there, aren't we? This is a fun little function for you to sort of study. It's the same thing as before, but we're not just passing in the address of a single value, we're passing in the address of a slice set to its 0 value. And so the idea here is what? We iterate over all the rows. This is where generics can come in amazingly. Just look at this code for a second, thanks to generics, because we don't have to use a reflection API. We can construct a slice of some type T to be determined later, like a slice of user. Then we can iterate over the rows, and then for every iteration, we construct a new value of some type T. We get back its address. This is already using reflection, so that works for free. And then we just append it to the slice using regular syntax, not reflection, because T does represent what? A concrete type. If you had seen this code prior to generics, this would have been impossible to read because it would have been a bunch of really ugly reflection API calls. This is where generics are winning because we can write the code like any regular Go syntax, just understanding that we're talking about some type T. User, product, home, whatever it is. Super cool stuff. Super, super cool stuff. Okay, so I think we brought in that support now. We've got the ability to do that named query to bring back the one record. So if I come back to the store, no big deal. Now we can, well, let's get back to where we were here. We were trying to deal with a token. So now I can get that user back. We've added the support to our business model. We now have query by email here. We've got query by email here, even though we're going to use the storage layer one to start. And then we're going to register these claims. Now, I've got a little complication here. Cannot use DB roles, variable type user role, as a slice of string in the struct. Super interesting, right? Let's go back to DB test. That is a slice of roles, and that is a slice of roles. That's a slice of string. Now, why is that a slice of string? Because when we were doing our coding at the time, we didn't have the user package, remember? And therefore, we didn't have the roles. So we could come now into auth and fix this. Now we're good. So refactoring that sort of back in. You know what that also means? It also means that now we have a database with users. Let's go back to our auth package for a second. Now that we have a database with users, we could also come back and do this. We could bring in our database connection in here now. And what we can do is on the construction, I don't need a fence, construct that user core and add user core to our auth. User core. Did I? Whoa. Oh, do you see inconsistency here that I missed? So we had a general rule on the last project in naming things. we would try to come up with 3-letter names, in this case, that didn't include a vowel. So user would be user, like that. You'll see that throughout this code. Product is PRD core. When it came to IDs, we used the full name. But when it came to these core names, we used this sort of syntax. Naming rules are really important for consistency throughout that's why you see ENV core here. So that should be user core there. And this should be user core to maintain that consistency in the naming conventions that we have. And even I missed that. When it comes to IDs, we use the whole name with the capital ID. But when it came to things like constructing a user value, it was the first 3 letters that did not have any vowels. Now, what if you had something like the word note? Because we had notes in the other system. I think we went with just NT. I'd have to look. We either went with just NT or NTE. But there's a rule that you have to set up, right? If you have only 2 letters, do you stick to 2? Do you maintain 3, which actually is better because as you start lining things up, everything's consistent? And if you go with 3, should it be the first vowel or the last vowel? I think we went with the last vowel. And that was a rule we had. And we can maintain that and we can do that, and the code was consistent. No matter anywhere in the code you saw the word note or user, you knew what it was. You knew whether it was an ID, a represented core, or a represented value of that type user. That allowed that code to have a better mental model of what's going on. These are hard things to maintain, but with a team of 3 or 4 people that care, you can do it. All right, I had to fix that. That was not good. Not good at all. That broke our naming convention here. Told you I was going to find things. Okay. So we've got that user core in here now. I can add the isUserEnabled method now to our auth, which I think we had in here. Thought we had in here. We did. Uh-oh. What does this need? Query by ID. Okay. But this was already getting called, wasn't it? Somewhere. There it is. Check the database. Okay. So this now requires that we query the database by ID, right? It's no big deal. We could do this really quick, can't we? What do we have to do? No big deal. We come back to our user model, our user business core package here. Again, no big deal. We understand what we have to do. We have to say that we now need support from the storage layer to query by ID. We assume that gets implemented. Then we come in here and we implement our query by ID. I told you this stuff gets boring and tedious once you've got this sort of laid out right. Boom, we have that. Now we need the implementation of our storage layer. Let's add that. We already have the model we need for this, so that's no big deal. This is it right here. Cool. Boom. Let's look at this. Select. Now notice I'm not saying star. Don't do a select star here, because if you don't have the same number of fields as you have coming back, and your models will all blow up. So the best thing to do is be very specific. I don't care how tedious it is, okay? So we select those fields from users where :user ID, we have our data model, name query struct, we can already do it, we get it back, we convert it back to a business level, a user value, and we send it back. Boom. Tedious stuff at this point, but it's all here. If there's a bug in this code, we only have to look at it here. Look at that. That means our auth is now good. We can actually check if a user is enabled or not. We've integrated that in there now. And we now have the ability to generate a token to make sure all that works. We've got all of that business layer code done.